Hi guys, so what we're going to do today is the opposite of last class. So last class we were given an equation and we sketched the graph. Today we're either going to be given the graph or information about the graph and we are going to write the equation. So in order to do that we need to be familiar with the three forms of quadratics that we talked about last class. So the one we did first was vertex form. That was the one that made it really clear what the transformations were. Then we also did standard form and root or factored form. All three of those are going to come back up today, so we need to be familiar with which one is which and what each of those things stand for. So on this first one, it says to write your equations in vertex form. So we're going to start with vertex form like we used last class. So we're going to start with that equation, f of x equals a, x minus h squared plus k, and we're going to use the information that we're used to, or fill in the information that we know. If the vertex is negative 3, 4, that's h comma k. So this is going to be x minus negative 3 squared plus k. A is that vertical stretch or compression or reflection. So it's going to be that 1/3 out in front. All right, look at the next one. So we know the vertex, but this time we don't know the a value. Instead, we're given some additional information to help us find the a value. So let's fill in what we know. So x minus h squared plus k. We don't know a. What we do know is that f of 3 is equal to 6. What that's telling us is that the point 3, 6 is on this graph. So when y equals 6, x equals 3. So what I can do is use that information to solve for a. So 3 minus 4 squared is negative 1. Negative 1 squared is 1. So a is 7. So now I can go back and write my equation. I know what a is, and I'm done. All right, let's try another one. Very similar. It gives us the vertex, and it doesn't tell us the a value, but it gives us information in order to be able to find the a value. So let's fill in what we know. The vertex is 6, negative 1. So this is the information we know. A root of 4. Okay, that doesn't mean we're going to use root form. Okay, that just tells us that the root is 4. That means that the point 4, 0 is on this graph. So when x is 4, y is 0. And then just solve for a. So add 1. 4 minus 6 squared is 4. A is 1/4. And don't just box a is 1/4. Remember, we're trying to find the equation. So we do need to go back and fill in that whole thing. All right, let's try the next one. Again, we're using vertex form. It doesn't tell us the vertex, but it gives us a ton of information that helps us determine what the vertex is. So first of all, it tells us the axis of symmetry. Well, we know the axis of symmetry is the x-coordinate of the vertex. So I know that my vertex is going to have an x-coordinate of 2. It also tells us the range, negative infinity to 4. Well, that means that my graph is going to look something like this, and the highest y value, the vertex, is going to have a y value of negative 4. And we also know it's going to open down. So we can fill in the information that we know. And then, again, it doesn't give us another point. It does give us another point. It tells us the y-intercept. So that means that 0, negative 12 is a point on this graph. So I can fill that in and solve for a. Negative 2 squared is 4. So I get that a is equal to negative 2. And I'm done. All right, so now let's look at some other forms. Okay, we want to write an equation in standard form. Now, just because we want the answer in standard form, sometimes it's going to be easier to use a different form to get there. So for example, this one gives us the zeros. If it gives us the zeros, we're going to want to start with root form because the roots are the zeros. So root form, x minus 1 root, x minus the other root. It also tells us the a value, so I'm just going to plug that in as 2. So one of these factors will be x plus 7, the other will be x minus 5. So now we have this equation in root form. So we have the equation of the quadratic. We just don't have it in the form that the question wants. The question wants this in the form, or in standard form. So in order to get this in standard form, all I need to do is multiply it out. All right, so what I'm going to do to start is FOIL those two together, multiply them out. So x squared minus 5x plus 7x minus 35. So that's x squared plus 2x minus 35. And then I can distribute that too. And now my equation is in standard form. All right, let's try another. So pretty similar start. It gives us the zeros. So even though we're not writing our final answer in root form, we can use root form to help us get our final answer. Sorry guys, wrong button. So this is going to be a x minus 2 and x plus 5. Now this time we don't know what a is. So just like we did with vertex form, we have to solve for a using the information we know. If f of 3 is equal to 4, that means when x is 3, y is 4. So the point 3, 4 is on this graph. So we're going to fill in y is going to become 4, and we're going to fill in 3 for our x's. So that gives me that 4 is equal to a is equal to 1/2. Now again, our answer is not a is equal to 1/2. That's just part of the equation. So now we have our answer in root form. Now we need to get it in standard form, following the same process as last time. Let's multiply it all together. So I'm going to FOIL these two first. So that's going to be x squared plus 5x minus 2x minus 10. So that's x squared plus 3x minus 10. Distribute that 1/2, and I'll write it over here. There's a little bit more space. So I get 1/2 x squared plus 3 over 2x minus 5. And now my equation is in standard form. So again, this is why it's helpful to be familiar with what these three forms are, what they look like, how to get there, and the easiest way to solve them. So in these cases, even though it was giving us the roots, and we want our answer in standard form, using root form made it easier to get there. All right, next one, the only x-intercept is 2. All right, so if the only x-intercept is 2, it doesn't mean that we just write f of x equals a x minus 2 and we're done. If it's the only x-intercept, that factor is squared. Okay, if the only x-intercept is 2, then that graph is going to look like this or like this. It means the vertex is on the axis. So this also really coincidentally looks like vertex form. All right, we still need to solve for the a value. It tells us the y-intercept is negative 12. So 0, negative 12 is a point on this graph. So negative 12 is equal to a 0 minus 2 squared. So negative 12 is equal to 4a. And now I know that the a is negative 3. And then at this point, it's the same thing we've been doing. We just need to multiply it out. Now remember, we need to be careful whenever you have a binomial squared like that. You cannot just square the individual terms. What you also cannot do, that you need to be very careful about, is you cannot distribute that negative 3 into those parentheses that are squared. That is not the same thing. Because remember, x minus 2 squared is really x minus 2 times x minus 2. If you were to distribute that 3, you'd really only distribute to one of them, not both of them. If you distribute it here, you're distributing it to both factors, which does not work. Okay, so do not distribute that 3 into the parentheses that are squared. You can only distribute it if those parentheses are not squared. All right, so let me just rewrite it so that we don't make that mistake. All right, so now I'll go ahead and FOIL this out. So it's going to be that square, double square. Now I can distribute, and I get negative 3x squared plus 12x minus 12. All right, so these next two are going to be a little bit heavier on the algebra. And these ones also are not as intuitive. So this first one, it tells us that it contains 3 points. It does not tell us that any of those points are the vertex. And in this case, none of these points are the vertex. So we want to write our final answer. It tells us we can use either form. So in this case, I'm going to go ahead and use standard form, just because that's the way we're going to set this up, and it'll make it a little bit easier. So standard form is f of x equals ax squared plus bx plus c. Well, what we're going to do is the same process that we did earlier when we were trying to solve for the a value. We're going to plug in the x and plug in the y in order to solve for the missing variables. The only problem here is that we have 3 variables that we're looking for, a, b, and c, which means we're going to need 3 equations. So for number 1, okay, take the x and y, plug them in. So 1 equals a times 0 squared plus b times 0 plus c. That's equation number 1. Equation number 2, 10 equals a times 9 squared plus b times 9 plus c. And equation number 3, 25 equals a times negative 6 squared plus b times negative 6 plus c. So now I'm just going to rewrite these equations a little bit simpler, make them a little easier to see. So this first one, 1 equals a times 0 squared, 0. B times 0 is 0. So 1 equals c. All right, we already have the first part done. One thing that might give you guys an indication on, if you notice 0, 1, that's the y-intercept. We know what the c value is in standard form. So one thing you probably notice, the c value in standard form is the y-intercept. All right, let's rewrite this next one. 10 equals 81a plus 9b plus c. And then rewriting this last one, 25 equals 36a minus 6b plus c. So now I have 3 equations, so I can set up a system. Well, this is going to be a pretty easy system to solve because even though it's 3 variables, we already know what c is. So we can take that and plug it in to both of those equations. So 10 equals 81a plus 9b plus 1. That's equation number 1. All right, but I'm going to go ahead and subtract that 1 from both sides and write it as 9. All right, then I can even make this even simpler. Everything in there is divisible by 9. So I'm going to divide everything by 9. And now I have a pretty easy equation. All right, let's take that second one. 25 equals 36a minus 6b plus 1. Well, again, let's subtract that 1, put all of our numbers together. And you'll notice all of those are divisible by 6. And now I have another pretty simple equation. So now I have a new 2-variable system that I can solve pretty easily with elimination. Add them together, and I get that a is 1/3. Plug that back in to solve for b, and I get that b is equal to 1 minus 3, which is negative 2. So now I know what a, b, and c are. So again, remember, our goal here is to write the equation in standard form. So it's ax squared plus bx plus c. And that is the equation that goes through these 3 points. Now, some of those may be harder to solve systems. If they are, if you have a calculator, you can use, what you remember about Gaussian elimination with the calculator and that reduced row echelon form to solve that system pretty easily if it's a really messy system. All right, this one here actually is a kind of a messy system. You have different numbers on your notes for good reason, so let me go ahead and rewrite those real quick. All right, so we're going to do an axis of symmetry of x equals 2, and it contains the points 5, 2, and negative 4, 20. Those would be a lot easier to work with. Okay, so this one, again, it says we can use either form. I'm going to use vertex form because that's going to be easier for the variables and the information that we have. So the reason I want to use vertex form is because I do already have one of the components of vertex form. If the axis of symmetry is x equals 2, then if I do f of x equals a x minus h squared plus k, I already know h. H is 2. So now I can fill in this information into x and y to write my new equations. And if I fill that in, I'm only going to have two variables missing, a and k. And if I'm only looking for two variables, then I only need two equations. So this is going to be a two variable system. So let's try this one. Oops. Let's fill in the first point, so 5, 2. So 2 is equal to, I don't know a, x is 5, h is 2, I don't know k. All right, equation number 2, 20 is y, I don't know a. When y is 20, x is negative 4, h is 2, I don't know k. So this is my system. Again, we can rewrite this and simplify it in order to be able to solve it. So we'll go ahead and do that. So I'm going to rewrite this as, this is going to be 2 equals 9a plus k. This is going to be 20 equals, let's see, that's negative 4 minus 6, that's squared, that's 36a plus k. All right, so we can use elimination, substitution, whatever you want to do. I'll do elimination, and I'll just rewrite this as negative. So I get that 18 is equal to 27a. So a is equal to 2/3. Once I know a, I can plug it back into one of those equations to get k. And now I can write my equation. So I know a, I know h from the axis of symmetry, and now I know k. So again, those last two, they're a little bit harder on the algebra. They're a little bit less intuitive, so those are probably the two toughest ones out of all these styles that we've looked at. But again, the more familiar you are with these equations and the different parts, the easier it's going to make these writing equations in general. All right, so now what we're going to do is we're going to look at some transformation type questions. So you saw these when we did absolute value. We're going to just do a couple more of these. So again, pay attention to the order here. Okay, the order does matter. So this first one, you have f of x equals x squared. Okay, we're going to shift it left 3 and vertically compress it by a factor of 2/3. So we're going to do that first. Well, left 3, that's f of x plus 3. Vertically compressed by 2/3, that's 2/3 times that. So that means this is going to become 2/3 x plus 3 squared. Now that we've done that, after we've done that, we are going to shift this up 1. Well, a shift up 1 is taking the f of x function and adding 1. So we're just going to take the f of x function that we already have and add 1. So pretty simple. But we got to be careful sometimes because the order sometimes is going to mess this up. All right, let's look at the next one. Horizontally compressed by a factor of 3/4. Shifted down 3. We're going to do that first. So horizontally compressed by a factor of 3/4 is going to go inside the parentheses and it's going to be backwards. And if I shift down 3, then I'm subtracting 3 from the function. All right, so 4/3 is going to go inside the parentheses. Down 3 goes after the parentheses. So those are our first transformations. Now that that's done, we're going to apply these new transformations, okay, followed by a reflection over the x-axis. A reflection over the x-axis is a negative f of x. So I take the function that I already have, I am making that entire function negative. So I'm doing a negative 4/3 x squared minus 3. Taking the whole function and making it negative, which gives me negative 4/3 x squared plus 3. All right, let's look at the next one. Vertically stretched by a factor of 3 and shifted left 7. So no order to worry about here, pretty simple. Vertically stretched by a factor of 3, that's 3 times f of x. Left 7 is going to be x plus 7. All right, so what we're going to do is we're going to take 3 multiplied on the outside. Bless you. Bless you. And then I'm replacing x with x plus 7. So x plus 7 minus 2 is really x plus 5. All right, then look at the last one. This is probably the hardest one algebraically. So again, we're going to look at that function notation to really help us out here. We're shifting left 3 units and 2 units up. So that means I'm doing f of x, whoops, sorry guys. I'm doing f of x minus 3, because that's right 3, and then plus 2. That's going up 2. So I'm going to apply these transformations first. F of x minus 3 means that I replace x with x minus 3. And then plus 2, just add 2 to that equation. So that gives me x squared minus 6x plus 9. Remember, don't square the individual terms. X minus 3 squared is x minus 3 times x minus 3. Okay, I actually have to FOIL it all out. That becomes minus 5x plus 15 plus 2. So this simplifies to x squared minus 11x and then plus 26. So that takes care of the shift right 3 and up 2. Well then, after that's been done, okay, we did all that math, then after that's done, we're going to reflect over the y-axis. Reflecting over the y-axis is f of negative x. F of negative x means you replace x with negative x. So this becomes negative x squared minus 11 times negative x plus 26. So that gives me a negative times a negative is still positive. This becomes plus 11x now, and then plus 26. All right, so the last two on there, we are just going to write the equation from the graph. Now, really, guys, this is the same thing you guys did at the very beginning. It's just you get the choice. All right, you can pick if you want to use the vertex, if you want to use the roots, which point you want to use. Really, these in theory are easier because you have more information that you can pull from, and it's really your choice. So on this first one, I'm going to use the vertex and a point. So the vertex here is 2, negative 1. And then I can use any point in this graph I want. I'm going to pick probably the clearest point, which is over here at 5, negative 4. So I'll do vertex form. I don't know a, so I need to solve for it. By plugging in negative 4 for y and 5 for x. Once you know what a is, then you can just fill it in to write the rest of your equation. Now the Desmos activity that you guys have today is going to be doing a lot of this where it gives you the graph. And it'll give you some points. By plugging in your equation, you'll be able to tell if your answer is correct. Now what you also can do is maybe look at this graph and use that to help you. Okay, I know typically I would go right 1 and up 1 from the parent function. And I didn't. I went right 1 and down something. I can't really see how far something I went. I can go right 2 and down, again, something I can't really see. I can also see that I've gone right 3 and down 3. Well, instead of going through all this algebra, you may realize typically based on the parent function, I keep saying pattern function, parent function, you usually go right 3 and up 9. Well, obviously there's going to be a negative. It's obviously opening down. But because you're going down 3 instead of 9, that's 1/3 of that value. In order to get there, you have to multiply it by 1/3. So that's another way that you can kind of help figure out what that stretch or compression is without going through all the algebra. There's nothing wrong with going through all the algebra, but if you can recognize that, it might save you a little bit of time. All right, now on this next one, it's hard to tell where that vertex is, so you may not want to use vertex form, but you're welcome to. You probably know that the x-coordinate is going to be halfway between those 2 points, all right, because again, we've talked about that. It's the axis of symmetry, so that might help you figure it out. It will be a fraction, and that's okay. But I'm going to go ahead and use root form just because you get practice using both. So my roots here are 0 and 3. So now it's in root form. Well, again, root form wasn't an option. It said standard or vertex. So let's go ahead and multiply this out to get it in standard form. So again, I'll pick a point. I'll use 1. This is -8. So that means that -8 is equal to a -2a. So a is equal to 4. Multiply it out to get it in standard form. And I'm done. All right, so again, being really familiar with these different forms of quadratics is going to make this day a little bit easier for you guys. Some of these days are a little bit algebra involved, so you're getting some good math practice in there. But that is it for today. After this, we're going to get into a lot of solving quadratics and a lot more of the algebra.